Geometry, Chapter 10, Section 1. We will begin a chapter on area, and we start with some pretty simple shapes. These would be your notes right here that you see on the screen. 3 area formulas that you ought to know: rectangle, parallelogram, triangle. Obviously, those figures are all figures we've already studied this year, but we did not study them in context of area. So here you have an area formula for a rectangle. I assume you're already familiar with this, but just a quick review. B stands for base, H stands for height. If I let this length right here be the base, the height would be perpendicular to it. It does not have to be the bottom. The B could be this one up here. This would still be the height. If I let this be the base, what's perpendicular to it would be the height. It's really about orientation. As you sit and look at this rectangle, if you turned your head 90 degrees and thought of the base as being what's to the bottom, or towards your chin, well, then the base and the height would be reversed from what you see labeled here. Secondly, area of a parallelogram is the same exact formula. Area equals base times height. The base, I often get this question when a diagram like this comes up on a quiz or a test or in the book. Are they talking about the whole length, or are they talking about just the partial length? It's about the placement of the label. So you can see that this B is right about in the middle from one corner to the next, one vertex to the next, that is. So clearly that B is for the whole thing. If it was offset more like right about here, well, then maybe it's talking about just from here to the intersection of the dashed line and that base. But no, it's talking about the whole thing. When in doubt, I would go with the whole thing. And I don't think that there are many, if any, problems in the homework that are confusing in that way. The reason that the parallelogram formula is the same as the rectangle formula is because really you could just take this triangle right here, pick it up, place it down right here, and what you would have is a rectangle, and it would be base times height. That's further evidence for the fact that the B is for the whole thing, right? So just to highlight that, the base is all of this, okay? Same thing with the triangle formula. The base that we're talking about, that's all of this right here. This whole thing is the base. Speaking of the triangle formula then, its area is equal to 1/2 base times height. We could go into proofs of this. I won't right now, but you could prove why it is that the area of a triangle is exactly the area of a rectangle formula. The easy way to see it, just as a simple one, is if I went back to my rectangle formula here and I drew a line that went from opposite vertex, one vertex to its opposite vertex, you've got 2 triangles there, right? So the area of this half triangle would be half of base times height. And that is why. Let's do a few examples. Pretty simple assignment here to start out our online learning. Here you have a parallelogram. The base is 12. That would be, again, the whole length from this vertex to this vertex is 12. The height is 8. You might wonder what that 10.5 is doing there. It's a decoy. It means nothing. They're trying to get you to use that in your formula when you don't need it. You've heard me talk a lot about work. I still need work on problems like this. And I realize we're doing online learning, and that's going to be hard for me to police. Impossible, I guess. But you'd be doing yourself good if you would just show this work. A for area equals base 12 times height 8. Okay, how long does it take to write A equals 12 times 8? And it'll serve you well if you get into the habit of this when we get just a couple sections ahead and we're dealing with things that are a little bit more intricate than this. Okay, now use a calculator if you need to. 12 times 8 is 96. When we're calculating area, we want our units in that unit squared. So this would be meters squared. Quickly, when you're measuring something like that's in one dimension, like a line segment, it's in meters, inches, miles, whatever. When we're measuring something that's 2-dimensional, like this parallelogram, or think of like the area of the floor in one of your rooms of your house, like maybe you're getting carpet put in or something, They measure that by the square foot or the square meter in the case of this problem. So we want 96 meters squared. Next example. Here it says a parallelogram is 9 inches, has 9-inch and 18-inch sides. The height corresponding to the 9-inch base is 15 inches. Find the height corresponding to the 18-inch base. I would highly recommend a picture here. In fact, if there's one challenging thing about this section, it's this example right here. So I would urge you for a problem like this to draw a quick picture. It said that we have a parallelogram that has sides that are 9 inches and 18 inches. Okay, it doesn't have to be a nice looking parallelogram. You know, my drawings are rarely nice. And here's 9 and here's 18. And it says the height corresponding to the 9-inch base is 15 inches. So that's like this. Actually, let me go ahead and make that a dashed line. When they say corresponding, they mean perpendicular to. Okay, that's an important point to make. When they say corresponding, the height corresponding to the 9-inch side. Oh, you know what? I did that to the wrong one. And I have not figured out how to edit videos yet, so you're just going to have to deal with my mistake for right now. The height corresponding to the 9-inch base is 15 inches. Now, what I could do is draw it like this. To do a better job of drawing it perpendicular, what I'm going to do is I'm going to extend the side out like this and then extend the height this way. It's still a height even though it's not up and down. You know, like a minute ago when I said the base is not necessarily the bottom, the height is not necessarily up and down. The height is perpendicular to its corresponding base. That's the wording they're using right here. The height corresponding to the 9-inch base. Here's the 9-inch base. We're not including any of this right here, just the 9-inch base. And then the height corresponding to it would be this right here, which we are told is 15. Okay, now we have an area formula for parallelogram. Notice that in the directions it says find the height corresponding to the 18-inch base. They didn't ask for the area. We are going to use the area to find what they want. The area being base times height, in this case would be 9 times 15. 9 times 15 is 135. And that is an area if they wanted it, right? This would be 135 inches squared. That's not what they asked for. They asked for the height corresponding to the 18-inch base. Now, what was I drawing a minute ago errantly? Is this height right here. That's what we're trying to find. We're trying to find that height. It's perpendicular to the 18-inch base. Now, here's what we're going to do. We're going to take the area formula, which is base times height, and we're going to plug in 135 for the area. And the base is 18. The height that corresponds to the 18 is the one we're trying to find. So now on your calculator, you take 135 and you divide it by 18, essentially solving this simple one-step equation, and that height is 7.5. The question is 7.5 what? Well, the explanation I gave you a minute ago, when we're measuring something that is a length, it's going to be in feet, inches, miles, meters. In this case, it's inches. This is H is 7.5 inches. Okay. To say that a different way, every parallelogram, and for that matter, every rectangle, has 2 bases and 2 corresponding heights. If I let the 9 inches be the base, 15 is the corresponding height. If I let 18 inches be the base, H is the height, which we just found to be 7.5. 7.5 inches. And there's their work for the same thing. Again, appropriate amount of work, just exactly what I showed you here. Picture would be optional. I think it's a good idea to draw a picture. All right, 3 more examples. Here's a triangle. Again, there's a base and a height, and then there's a leftover number, a number that you will not use. The 30 is the base. From Y to Z would be 30 centimeters. 13 corresponds to that as a height. The 31 is nothing. Leave it out. And write your area formula is 1/2 base times height. That would be 1/2 of 30 times 13. And use your calculator as you need to. I get 195. Work and answer. 195, this would be centimeters squared. Work and answer. Okay, one more example from the Print Us All software, and then I have one more after that selected to just practice example 2 one more time. Actually, I'm gonna leave this one out. So we do just have one more example. I'm gonna leave this one out of the homework too. Okay, so just one more example. This is a lot like example 2. The height that corresponds to the 12, let's give this some units. Let's say feet. These are all in feet, okay, 8.5 feet. The height that corresponds to the 12-foot base would be 7.2 feet. I could calculate an area, the area of this parallelogram. By the way, we should be told that it's a parallelogram, or you could have the symbols that show you that something is a parallelogram, right? So I did leave that out of my directions. The book will not be ambiguous there. Either you'll be shown that it's a parallelogram by the markings on the diagram, or it'll say that it's a parallelogram. Anyway, the area would be base times height, 12 times 7.2. I'm using my calculator. That's 86.4 feet squared. We want to find x. The directions say find the length of x. This x is actually a height that corresponds to the 8.5 foot base. Again, let me just point out, on this diagram, as with when we write quizzes and tests, and I know that you're in quarantine, so you're not taking my quizzes and tests, but it's still worth saying that we only have the ability to write things in black and white. Right? Your book can do a little bit more with color. On the starboard, I can do a little bit more with color. But if it's just black and white, you need to realize that the dashed lines don't actually have anything to do with the figure itself. The figure is the solid line segments that is this parallelogram. The dashed line here is just a side extended. The dashed line here is to come perpendicular with that side extended. That would be the height. X is the height. I want to find x. So the area, which is 86.4, is equal to base times height, the base being 8.5, the height being x. That's 86.4 is equal to 8.5x. And again, I go to my calculator. Notice the directions say to the nearest tenth. So as I solve this, I take 86.4 and divide both sides by 8.5. Divide 86.4 by 8.5. I get a pretty wild decimal, 10.16470588. To the nearest tenth, that's going to be 10.2. Follow the directions and what it says to round, and make sure you're rounding correctly. Round to the correct decimal place and round correctly. 10.1647, that would be 10.2 feet. Good luck on the homework.